How Current Affects Transmission of Power by KayScience.com. How current affects transmission of power is what this video is going to focus on. Here we have a series circuit where the cell causes the current to flow around the circuit. As the current flows, energy is transferred by the electric current. As the electric current continues to flow around the circuit, resistance causes the heating effect. These red arrows represent thermal energy dissipating into the surroundings as the metal wire warms up. So, as resistance causes the heating effect, this then results in thermal energy dissipates into the surroundings. As the thermal energy dissipates into the surroundings, power is wasted. To calculate the power wasted due to the heating effect, the equation is P equals I squared times R. That's power equals current squared times resistance. It's question time. Attempt these questions to check your understanding. Power equals current squared times resistance. This is the equation to calculate the power wasted due to the heating effect. The equation can be simplified to P equals I squared times R. So you need to know P equals I times V is equal to P equals I squared times R. So in this equation, P is the power supplied to the resistor. And this equation shows how P is proportional to the square of the current. So this just means if the current is doubled, the power is 4 times greater. For example, if I equals 2 amps and R equals 10 ohms, then 2 amps squared times 10 ohms equals 40 watts. If we then double the current, so I equals 4 amps, and we plug this into the equation, then 4 amps squared times 10 ohms equals 160 watts. So this equation shows when the current is doubled, the power is 4 times greater. It's question time. Attempt these questions to check your understanding. This worked example shows how a lamp has a current of 3 amps and a potential difference of 230 volts. There is a resistance of 12 ohms. Question 1. How much energy is transferred each second? And question 2. How much power is wasted? So the first question is asking us to calculate how much energy is transferred each second. Calculating how much energy transferred each second is just another way of saying power. So we have to calculate power. So I'm going to write down P as this is what we're going to be calculating, power. The question gives us a current of 3 amps and a potential difference of 230 volts. So the equation we need is P equals I times V. Power equals current times potential difference. So the question tells us I equals 3 amps and V equals 230 volts. We then plug this into the equation where P equals 3 amps times 230 volts. So P equals 690 watts. Now the second question is asking us to calculate how much power is wasted. To do this, we use the equation P equals I squared times R. The question tells us I equals 3 amps and the resistance is 12 ohms, so R equals 12 ohms. We then plug this into the equation where P equals 3 amps squared times 12 ohms. From this, P equals 108 watts. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.